Hey FJA students, I just wanted to make a quick tutorial video with specific regard to number 3 on your lesson 1 greatest common factor. Show it. I've had a couple of questions about this. The questions arise, I think mostly because we've got two ways to find greatest common factor. You can list out all of the factors. So that just means you are going to go through each number that you're trying to find factors of, and you're going to divide it by different numbers and just find out what whole numbers are factors of that number. And then there's the other way with prime factorization. So on number 3 in the answer key, we solved it with prime factorization, but that doesn't mean you can't solve it the other way. And if you did solve it the other way, that doesn't mean that you're wrong at all, because there are two equally good ways to solve this. And so I'm just going to walk through this problem with you all using both options. So we're going to find the greatest common factor of 12, 60, and 68. So let's first do it by listing out all of the factors. Okay. So 12 should be not too bad. And I'm first going to do this using long division. But after that, if you need to use long division, then that's totally fine. But I'm probably going to go a little bit faster than that. So let's see, 12. We know that 12 is divisible by 2. Okay, so 2 is one factor. And the other factor is what you multiply 2 by to get 12. Because remember, factors are two numbers that you multiply together to get a product. So in this case, 12 has the factor of 2 and then 6. Also, if you divide 12 by 3, let's check it out. What do we get? If we divide 12 by 3, if we get a whole number, then we know that 3 and that other number are factors. So 12 divided by 3, 3, 6, 9, 12. So that's 4. Okay, so we've proven that 3 and 4 are also factors. And of course, last thing that we always know about any number has a factor of 1 and itself. So those are all of 12's factors. Okay, there we go. 60 is going to be a little bit more difficult. Okay, we've got 60 here. Let's start with just 1 and itself. I also know that 60 is a multiple of 10 because 10, 20, 30, 40, 50, 60. So 10, and you would multiply 10 by 6 to get 60. So 6 is another factor. It's an even number, so it's divisible by 2. But that off the top of my head, I'm not entirely sure. So let's do that. 60 divided by 2. 2 goes into 6 3 times. Subtract 6 from that. Got 0, bring down the 0. Oh, so 2 goes into 0 times. So another factor is 30. Let's erase that really quickly here. And let's see, what other options? Oh, I actually think if I divided 60 by 3, I'd get an answer. So let's see. 3 goes into 6 2 times. So that's 6. 0, 0. So we have 20 and 3 are factors of 60. And I'm pretty sure I could maybe divide 60 by 4 even. So let's see. 4 goes into 6 once. Subtract 4. 2, 0. 4 goes into 20 5 times. Subtract 20. You get 0. So we've also got factors of 4 and 15. Cool. So you can see how this is a little bit of a time-consuming process. And so 68, let's do that in a different color here. 68, well, 1 and 68. We definitely know that. It's definitely not divisible by 10 like that one was up there. But it is an even number, so let's just figure that out. 68 divided by 2. That's 3. 3 times 2, 6. So 34. Yep. All right, so 2 and 34 Because I know my math facts pretty well, I know that it's not divisible by 12. 12, I know that that's not divisible by 12. I can also tell it's not divisible by 10, like we talked about. It is divisible by 2. We could check if it's divisible by 3, but I do kind of doubt it. And here's why I doubt it. And I'm not even going to do it. So I know that 3, right, went into 60. We wrote that down as a factor there. So 3 goes into 60. That means if you add one more 3, we'd get to 63, and then 66, and then 69. And since 68 isn't one of those numbers, then I know that 3 doesn't go in there. But let's try 4 maybe. So 68 divided by 4. So 4 goes into 6 once. Subtract that 4. We got 2 as a remainder. Bring down our 8. 28. 4 goes into 28, does it? Indeed, it does. And it goes in there 7 times. So 7 times 4 is actually 28. Track that, 0, 0. So we also know 4 and 17 are factors of 68. All right. I think that's about it. Actually, we should probably check for 6. So 68 divided by 6. 6 goes into 6 once. 6 there. 0. Bring down that 8. 6 goes into 8 once as well. So subtract 6 from there, and then we get 2. And as soon as we get to a decimal when we're checking for factors, then we know we have gotten to a partial quantity, a decimal number. And so 6 wouldn't be a whole number factor of 68. So these are the factors we're going to work with. And now the real easy way for us to do this here is to just see what our greatest common factor is. So it looks like 2 is a factor of all of them. Okay. 3 is not. 3 goes into 12 and 60, but I don't see a 3 for 68. So 68 is not divisible by 3. 4 is a factor of 68. It's also a factor of 60 and of 12. Cool. 12 is a factor of 12, but not of others. Okay, so it's not going to be 12. 6, I see 6 for 12 and for 60, but 68 does not have a factor of 6, so let's cross that out. I'm not really seeing any other common factors, and so really what it appears like here is that 4 is our answer, and so that's D. And in fact, you can see that is the answer, but you can see that they arose at that answer from using prime factorization. And so what I'm going to do really quickly here is just go over once more how to do prime factorization. And this is definitely a little bit of like a magical, almost like a trick that you can do with math. So follow along. So our numbers are 12, 60, and 68. So what we have to do is we have to do prime factorize. We have to prime factorize 12, 60, and 68. So I'm going to do that with us really fast. So 12, remember to do prime factorization, you're going to find one prime number that goes into this number, and then the other number you multiply it by to get 12. So it's an even number. I always start with 2. 2 times what is 12? Oh, the answer is 6. So 2 times 6, that's our other prime factor. So we circle our prime numbers. That's why I circled 2. 6 still has prime factors. So we haven't gotten down to the prime number there. So we're going to find out what 2 numbers are a factor of 6, and we're going to look for a prime number. Well, it's still an even number. So we know 2 is a factor of every even number. So let's put 2 there. 2 times what is 6? Well, 2 times 3 is 6. And I'm going to circle 3 as well because 3 is also a prime number. It is only divisible by 1 and itself. Okay, so we have found the prime factors of 12. I'm going to write them down here. 12 is 2 times 2 times 3. Those are the prime factors. If you were to multiply 2 times 3, you get the number 12. We're going to repeat with 60. So again, 60 is an even number, and I just really, really like being able to start with 2. So we've got 2 as one factor, and 2 times what equals 60? Pause here if you need to do the math. Well, half of 60 is 30. So 2 times 30, double 30, is going to be 60. All right, 30 is not a prime number, so we're going to find the factors for it. Again, even number, so you probably can guess what I'm going to do. I'm going to say, well, we can divide it by 2, so that's an easy prime number to get. 2 times what is 30? 15. So 15, still not a prime number because it has factors other than 1 in itself. I know that 15 is a multiple of 5. I'm going to put 5 over here. And then you multiply 5 by 3. Are either of those prime numbers? Well, actually, both of them are. So 3 can only be divisible by 3 in itself. 2 doesn't go into 3. Nothing smaller than 3 goes into 3 other than 1. And then 5 is also a prime number. So if you really need to review prime numbers, I would definitely recommend getting online and watching some videos about what prime numbers are and explain that, okay? Because that's confusing to you. This is going to be a really hard process. So we've got our numbers for 60. 60's prime factors are 2 times 2 times 3 times 5. All right, and then last one here, let's do 68. Again, I'm going to start with 2 because this is an even number. 2 times what? The answer is 34. Oh, 34 is still even, so I know I can have a 2 as a factor again here. 2 times what is 34? The answer is 17. Does 17 have a factor? Oh, actually it does not. 17 is a prime number. So our answer down here for 68's prime factors, 2 times 2 times 17. So this is where the magic of finding the greatest common factor using prime factorization comes in. And so here's the rule. In order to get the greatest common factor of these 3 numbers, you are going to find the shared prime factors. So I can see that they all have in this row here, or this column, they've all got 2 as a shared prime factor. And then right here, they've got another 2 as a shared prime factor. 12 and 60, they share 3, but 68 does not. So if we're looking for the greatest common factor of 12, 60, and 68, we can't look at 3. 5 is only in 60's row, and 17 is only in 68. So the shared prime factors for 12, 60, and 68 is just 2 and then another 2. And so to find the greatest common factor, you are going to multiply the shared prime factors, 2 times 2, and that equals 4. And that's pretty awesome because using this method, we were able to come up with 4. And back here, we were able to come up with that same answer using the other method where we just find all of the factors and then go through and figure out what is the largest common factor. So 2 methods to do the same problem. I hope that clarifies some things for you all. Don't feel like you absolutely have to totally memorize how to use prime factorization. If you like the other method, that's great. If prime factorization works for you, that's also fantastic. Thanks for tuning in. I hope this is helpful.